Elegance and simplicity are key to succeeding as a hypermodeler, and I encourage you to seek out Azad Madni's paper, Alejandro Salato's work, and Bill Schindell's work as well. Each of them has contributed important thinking to elegance and simplicity in systems engineering. And from software engineering, there's two concepts that are relevant to us. Dry, don't repeat yourself, and wet, write everything twice or waste everyone's time. Part of hypermodeling is to not create something we can derive through relationships and other properties. We basically don't want to repeat ourselves at all. So we work very hard to be dry with the development of a hypermodel. Clarity is also important. Ryan Noguchi, a colleague at Aerospace Corporation, has compared document-intensive systems engineering, DICE, to lossy compression, in that information is lost at every step as one person's intent and content are transcribed to English and then reread and reinterpreted. It's like playing telephone as a kid, where you whisper one thing in the first person's ear and what you get at the other end is very different. On the other hand, models are lossless by nature, and so I agree with him completely that a well-executed system model is a lossless way to capture intent and transfer to downstream individuals. Kelly Johnson, whose biography I referenced in an earlier video, had some really great thinking, and he talked about the skunk works using the simplest, most straightforward methods possible to develop and produce new projects. It's why the SR-71, U-2, and a lot of the other work the skunk works did succeeded, whereas aircraft like the XB-70 Valkyrie from North American were failures. And so again, we're trying to apply the simplest, most straightforward methods possible to achieve our goals. Yep, and Johnson also recognized there was no one way to build all airplanes. I'm very much opposed to the mindset that we just have to work out a perfect process and just turn the crank and good engineering will flow. And that's why I don't like a lot of the architecture frameworks and other efforts out there, because I think they're too prescriptive. We need to have solid methods that people can apply competently to capture relevant information in a manner that's appropriate for their system. Now, that's not to say that an organization can't impose some modeling rules or guidelines to serve its own needs and ensure interoperability between its own models and systems to share information, but I don't think we need to have someone from on high dictating to us how to name maximum voltage for a given system or something like that. So there should be conventions, but I think we need to allow the maximum amount of freedom within the modeling community to do what's right to serve our customers and clients and stakeholders. So key takeaways that I think you should have. Number one, you want to have a simple, direct approach. You want to minimize the number of customizations. If there's a way to do it with the stock tool or stock SysML, let's do that. Let's not needlessly customize. We want to minimize the number of elements and relationships, because to create and maintain an element or relationship takes time and effort. We don't have enough time to do everything, so we want to minimize waste in this process. So again, minimize the number of elements and relationships you create. And again, challenge yourself to find a way to represent all relevant information directly in the model so it can be the authoritative source of technical truth, or at least be one hop away, that if you have a value or a piece of information that's then hyperlinked to the authoritative source, but you have the relevant piece of information captured in the model as well, so it's exposed to the people consuming the model directly. So where did the name hypermodeling come from? Well, I was looking for a title to capture the mindset of elegance, simplicity, speed, directness, and I came up with a couple names: elegant modeling, direct modeling. Again, I wanted that feel for simplicity, speed, and elegance, and my wife suggested hypermodeling because of hyperdrive and science fiction, that you can get to the destination faster than via ordinary means, and I thought it was catchy, so that's why I've adopted hypermodeling as the term for this approach. So these 10 Commandments of Modeling previously were presented in a variety of my presentations at No Magic and Cozy, but I want to repeat them here because they may be new to some of the audience. So these are my 10 Commandments of Modeling that I've tried to communicate to my modeling teams. Number 1, you will not make shelfware. We do not model just to create documents or output that gets put on a shelf. If it's not used, we're not doing it. We don't add any model element without reason. There should be a rationale behind everything we add to a model. We do not add any model elements that can be derived. Again, we want to minimize the amount of work we're doing, and if it's a derived element, it's automatically in sync. If I change a property that's 3 hops away through relationships, I'm not forced to keep multiple things in sync. We will document all of our model elements as far as the key critical blocks, operations, use cases, not necessarily every relationship, but we want to document as much as possible to capture relevant information. We will not leave things without units. If it's a measure of something, it should have a unit. pounds, kilograms, amperes, whatever the appropriate unit is, capture it in the value property or tag so there's no question later. All model elements should be typed so we don't leave dangling untyped part properties or other things. Everything should be typed appropriately. The modeler will keep in mind that a modeling effort is about integrating content and helping the model grow organically. We are adding content and helping the model grow from an infant to an awkward teenager to a capable grown-up. It's all about organic growth. We also need to make sure we delete unneeded elements to prevent clutter. It's very easy to let a model grow and bloat with garbage if it's not appropriately deleted. So there has to be an ongoing garbage collection effort to keep the model clean and tight. You can't be afraid to say no to a stakeholder or person who wants you to do things that aren't in the best interest of the model. And that basically is the final commandment there. Always do what's right for the model. It's the purpose of the modeling team to grow the model and make it useful, and they have to own the stewardship of the model itself. It is what they tend and grow. The greatest commandment of all of these is that you should ruthlessly subordinate your approach to what the modeling tool does easily and well. There's no point to try to model and automate document-intensive processes with their inherent inefficiencies. We can't be afraid to tell stakeholders no if giving them the last 2% of what they want costs us 30% more time. Unless there's some overwhelming business need and the project will fail if we don't do it, there's no reason to expend that extra level of effort to placate someone. And it's particularly difficult when you're trying to transform this requirement-centric culture into a behavior structure interface culture in which we use the model to project text-based requirements as necessary and don't use them to drive it. So this can be very challenging when you're in the middle of a culture change, but keep it in mind. I'd like to point back to Fred Brooks, the author of Design a Design that I mentioned in the earlier video. And he at one point said, "Show me your flowcharts and conceal your tables, and I'll be mystified. But if you show me your tables, I won't usually need your flowcharts, they'll be obvious." And that came out of the Mythical Man month written in 1975. And I agree completely. Most of the work that we'll be doing in hypermodeling will be with tables. We use the diagrams as a means to create certain relationships and information, and in certain rare circumstances they are more clear, but in general the tabular information we generate is far more useful than a diagram. So keep that in mind. And this is thinking that goes back over 40 years. Also keep in mind you're probably not going to hit a home run with your first at bat. You know, Fred Brooks also said that you're going to throw a pilot system away. Plan to throw one away, you will anyhow. And I would encourage you that as you begin your hypermodeling journey, realize that you're probably going to end up tossing your first attempt. So I encourage you to create a sandbox on the side, play with it, model it. Even if you are starting on a for-real project, be ready somewhere along the line to scrap it and start over. You know, re-import the information, repurpose what you can, but you're probably going to have to start from scratch at some point. Now, here's the equation that I made part of the trailer, and I've been tossing around, and it's eta epsilon equals phi. And let's see what we mean by that. It's efficiency, effectiveness, and elegance. So eta is the efficiency factor, and I'm defining that as some ratio of output to input that will always be less than 1. You're always going to get less out than you put in, so 0 is less than eta, less than 1. Epsilon is our effectiveness factor, which is a number for the ability to accomplish our desired or intended outcome. And again, I'm defining that as being between 0 and 1. So therefore, as a result, the elegance value, phi, has to be between 0 and 1. And so we have this relationship where we just multiply efficiency by effectiveness to get our elegance quotient. Unfortunately, this is actually a little more complicated in that language, tool, and method all contribute to this equation. And so it's eta epsilon for the language, tool, and method all multiply. So if those aren't all close to 1, pretty soon phi is very, very much reduced. And so the other problem we have is that once you've picked your tool and language, those are basically constants. You cannot change them anymore because the tool and language they are what they are. And so the only thing you really can contribute to and modify is your eta method and epsilon method. Keep that in mind as well. And I picked phi because it's associated with the golden ratio, which is, I think, is a reasonable symbol for elegance. And so by definition, phi is less than 1. The golden ratio is 1.62. I realize that. And again, the intent is to help us develop a method that maximizes elegance by emphasizing our most simple, direct approach to rigorously capturing relevant information. And keep in mind too that 2/3 of the terms in our equation are defined by probably someone other than you. If somebody else picked the modeling tool in the language, they painted you into a corner with those choices. And so, again, I'm hoping that you have a tool that's useful to you, and that you are at least using SysML to do this. So at least those pieces are as high as they can be, or have the greatest value possible. And now it's all up to you with the method.